In this example, I'm going to try to show you the very easiest way I know of for using the sum and difference formulas when you get bigger angles like what we're trying to figure out here, the cosine of 195 degrees. So 195 doesn't play very nice with the angles that we like using, which tend to be 30 degrees, 45 degrees, and 60 degrees. So let me show you exactly how we can get it rewritten in terms of those angles. And to do so, what I'm going to suggest is we use a reference angle. So initially what I'm going to do is just go ahead and sketch a quick graph of where does 195 degrees fit. Well, it's bigger than 180, but it's smaller than 270. So if I wanted to place this into a quadrant, it would be in the third quadrant. It's going to wrap all the way around here for 195 degrees. And then if I want to draw in our reference angle, that reference angle always fits between wherever our initial angle landed, right? The terminal side and the x-axis. So this little red angle that I'm drawing in here, that's where the reference angle is. So I'm going to go ahead and say our reference angle, the red angle, is theta bar. Let's go ahead and calculate that theta bar. So theta bar will be, you'll take the longer angle going around, 195, and you'll subtract away the shorter side, so the 180. And this works out to be 15 degrees. All right, so we'd like to replace 195 degrees with 15 degrees. So let's think about how we can do that. So cosine of 195 degrees is going to be equivalent to cosine of, using our reference angle, 15 degrees, as long as we're careful about, we were in the third quadrant with 195 degrees, we have to make sure that the sign, positive and negative sign for cosine, is correct. So to do that, I like using the phrase, all students take calculus. What this reminds us of is which trigonometric function is positive in each quadrant. All of them are positive in the first quadrant, sine is positive in the second quadrant, tangent in the third, and cosine in the fourth. So because our angle landed in the third quadrant, that means only tangent is positive, but cosine, the one we're dealing with, is going to be negative. So I need to include a negative out in front as soon as I plug in that reference angle. Okay, next we need to pick out which two either add together and make 15 or subtract and make 15. So we have choices here. If we use 60 minus 45, that makes 15. Or we could use 45 minus 30, and that also makes 15. So the choice is really up to you. We would get the same exact solution in either case. We just have to make this decision, which one do we want to use. So it doesn't matter to me. I'm not going to go through both of them on this case. And so let's go through, I don't know, it doesn't really matter. I'll do 45 minus 30. So let's rewrite this. We're going to have the negative comes along step by step. This will get to be cosine of, and I'm going to try to kind of color code this as we go through. I'm going to use blue for my 40. Nope, that's not blue. Let's use blue wherever we see 45. And then we're going to subtract. Let's use yellow for our 30. All right, and why I'm doing this is I want it to fit into this difference formula at the bottom here. So wherever I see an alpha in our formula, like that alpha, it's going to match up, and we're going to replace each one of those with a 45. And in our formula, I'm going to use beta is going to correspond with 30. So wherever we see a beta in our formula, trying to color code this, make it nice and easy, we're going to replace that with a 30. So bringing everything along, I'm going to go negative of, and I'm just going to go ahead and big set of parentheses here, rewrite the right-hand side of the formula. So it goes cosine, cosine, plus sine multiplied by sine. Close that big set of parentheses. Okay, remember our filling in, wherever we saw an alpha, 45 is going to go there, 45 is going to go here. And I'm not writing my degree symbol along the way, but this is in degrees the whole way through. All right, betas are going to get replaced with 30s. So there we had a 30, and another 30 goes here. So let's just fill in to the right-hand side of the formula, kind of replacing each of the alphas with 45, betas with 30 degrees. From here, it's just a matter of using these known angles, and hopefully you kind of memorize these along the way. The cosine of 45 degrees is going to correspond with square root of 2 over 2. Multiplied by cosine of 30 degrees is square root of 3 over 2. Plus sine of 45, square root of 2 over 2. Multiplied by sine of 30 degrees, it's going to work out to be 1/2, and I'll close that big set of parentheses. From here, just go ahead and simplify what we can. Go ahead and say that negative's out in front. Not dealing with it yet, so I'm bringing the parentheses along. And now I'm going to go ahead and multiply our fractions together. So square root of 2 times square root of 3 for that first numerator makes square root of 6. Over 2 times 2 for the first denominator makes 4. Plus, again, multiplying numerators, square root of 2 times 1. Multiply denominators, 2 times 2 makes 4. Maybe we'll clean this up, give it a little bit nicer finished look. I'll put a negative out in front, but we have common denominators. So let's go ahead and combine these fractions together. Keep the common denominator. Go ahead and say square root of 6 plus square root of 2 goes in our numerator. And that is our final answer. So the big challenge really is picking out reference angles, understanding those, getting comfortable with them, and then going through and really just picking out 30, 45, and 60, which combination can we make that either add together and make the reference angle or subtract to make the reference angle. Now, a very common mistake that we see along the way on these is students forget to remember about positive and negative when using the reference angle. So that's why that all students take calculus mnemonic device really helps me in remembering exactly which quadrant is going to be positive, which quadrants things are negative. All right, hope this helps out. Good luck as you're working through these sum and difference formulas for trig functions.